Hi, welcome to this video. So today we will learn about lemma of the Gauss. So what it states that, let's say for any odd prime p, let's take a be an integer, such that what is happening means GCD with p is equals to 1. So from this what you can declare means, since p is a prime number, you can write that like p doesn't divide a. So consider integers a, 2, 2a, 3a and so on, and p minus 1 by 2 a. So apart from this set, this is the set having how many elements, tell me? 1, 2, 3, 4 and so on, p minus. So total number of elements is p minus 1 by 2. And their least positive residue modulo p means, consider like this set. A percent p. See, first of all, percent means mod, in my terms. So a percent b is nothing but like actually a mod b. A mod b means what? What is the remainder of when a is what is the remainder when a is divided by b? This means that what is the remainder when b divides a, something we write it in long division format. So whatever the remainder is, this remainder we are calling known as yes. Nice. So I'm a percent b. So now consider this least positive residues modulo p. So you know what is residue. So residue of a modulo p means a percent p. Like that. So least positive residue means a percent p, 2a percent p, 3a percent p and so on. How much? p minus 1 by 2a percent p. Happy? See, remember that we can comment out that what is the value of a percent p? It can lies between 0 to p minus 1. This is simple thing. Normally we know that a percent p. So to talk about only positive remainders, the values can possible with me how many p values possible, and those range of values will be 0 to p minus 1. Let's talk not about this. Let's go to directly jump. So what now I'm writing the theorem. So here comes the actual thing. So if let's say n equals to, n denotes number of residues that exceed p by 2. Number of residues means in this set, see, I told each and every value will be lying between 0 to p minus 1. Means in this set some of the values will be greater than p by 2 and some of the values will be less than p by 2. I will write neatly, don't worry. So I'm saying such n denotes such number, which is exceeds p by 2. So then a by p is equals to minus 1 whole power n. So see, first of all, what's new here is generally a by p is always congruent to a power p minus 1 by 2 mod p. So generally a comma legendary symbol of a by p equals to, it can be, tell me what, 1, minus 1 or 0. 1 will be happen when, tell me, when a is a QRP. When a is a QNRP means quadratic residue p. Here non-quadratic residue modulo p, and 0 when p divides a. Now so since we are considering a comma p as a 1, that means p doesn't divide a. So we are not talking about this case. So now just by knowing this information, means by knowing only A comma P GCD equals to 1, I can conclude that A by P can be 1 or minus 1. Okay, samjha? Happy? A by P can be 1 or minus 1. This is normal fact. It is always true. So let's say if I want to comment exactly, I want to know exactly the value. So is exactly A by P equals to 1 or minus 1 means answer is depends on. Okay. So but I can by somehow, this is the beauty of theorem, lemma of the Gauss. This beauty of theorem says that A by P equals to definitely equals to minus 1 whole power n. By a, what is n by a means? This by a. N by a means, so consider this set means calculate all these values. Okay, and so on, P minus 1 by 2 into A modulo P. So calculate all these values such that n is that all these values, okay, value should be greater than P by 2. Okay, this value should be greater than P by 2. Suppose let's say it came out to be like 5, 4, 7, 9, 10, 2, 3, something like that. Okay, and let's say I am having P value as a, let's say suppose 19. So P is equal to 9. P by 2 means how much? 19 by 2. So 19 by 2 means how much? 9.5. Okay, so now tell me whether this is 9.5 or not. Above 9.5, not. Above 9.5, not. Above 9.5, not. Yes, not. So in this case n value will be how much? Bhaiya, tell me. N equals to 1. So basics, this is basic common sense. Okay, this is how you have to understand. See, this is, see, if you see at the beginning it will look like a monster, but it is not. See, it's like bacha. Okay, so okay, happy, that's it. So consider this set, count the values which is having the P by 2, that is the value of n. So substitute here, then you will get the exact value, whether it can be minus 1 or plus 1. Okay, this is how like you have to think. This just application wise only. Okay, happy, that's it. So I will remove this thing. So okay, let's go to proof. In this proof, okay, one thing you have to know about, let's say one property I have told in the last class also. Yeah, I have told one property for RRSM means RRSM P. So what is the property means? Let's say RRSM P. Okay, let's say RRSM something, some random number m can be anything, positive, composite or prime. So let's say am I having how many, see, I'm having all these values, okay, to phi of m. Okay, it is the rule. Okay, just remember that this is called cardinality of the set. Cardinality of the set means number of elements in the set. Number of elements in the set means how many, tell me, means how many, phi of m. Okay, happy. Now let's take a be any integer such that what is it should satisfy GCD of a comma p equals to 1, a comma m equals to 1. Then I can say that AP AM A into R1 or A into Ri belongs to RRSM M for all I belongs to, tell me. So for all I belongs to 1 to 5 of m. Okay, you understand the point? So take a integer such that the GCD should be 1. If I multiply, it will always belongs to RRSM M. That's the property. Okay, good thing. So this is what I am writing. Okay, property 1. So let's say AJ belongs to RRSM P if J belongs to RRSM P. Okay, This is the property. So happy. So let's consider this as, let's name it as S. S is a 2a, 3a and so on, p minus 1 by 2a. Okay, and take, let's consider the set b1. So let's say b1 is, let's say, what should I to keep, means which notation will be better? Okay, let's go by R and L. Okay, R means right, L means left. So let's bi is a bi. So from this set, pick the elements, not from this set. Okay, so consider the S mod p. Like SAR has written like in this format, I am also writing. So S mod p means this is the set, and so on. How much? P minus 1 by 2 mod p. So in this set we are having, this is the value. Normally we can comment out by normal, even Bach also comment that this value will belongs to 0 to p minus 1. But I am saying in this value, some values, okay, some values will be greater than p by 2. Okay, some values will be greater than p by 2 and some other values will be less than p by 2. Okay, just like I have seen previous, I have taken some integer, some set of values, and I have told that particular number is value of n. So similar like that, the value, so consider, means I am saying that partition this set into two sets. Okay, just for purpose, deriving purpose. So such that one set will be having all values greater than p by 2 and another set is having all values less than p by 2. I am calling this set, what should I, better name is, let's say b1. Okay, greater than p by 2 is b1, less than is to p2. Okay, happy. So how to write in mathematical form? So mathematical form is nothing, means equals to bi such that how much, r1. Okay, r1 rk, where k is equals to 1 to n. Why I am writing 1 to n? Because see, understand here carefully that in the question only I am saying that n be the number of residues which exists p by 2. So number of which exists p by 2 means this is nothing but this set only, na? So this set cardinality how much, n. So I am taking the values will be like this, like r1, r2 and so on, rn. Okay, happy. This is the basic thing. What is the rk? Rk is nothing but it should be of the form something a into j mod p. Okay, wait, okay, that is what I have written. Happy, that's it. Let's say a into j mod p, where j belongs to 1 to p minus 1 by 2. This is what I have written. Similarly, tell me b2, let's take, this is right, this is left. So take li, just for a sake, I equals to 1 to how many number of elements present in this set? Tell me. This is p minus 1 by 2. Why so means c. Now tell me, let's say I am having all numbers which is in the ascending order. So how many elements will be present here? 6. Just like here, 1, 2a, 3a, 4 and so on, p minus 1 by 2. So last number will, so this is the set of, this is the set S mod p. Okay, cardinality of S mod p. So now I am dividing into these two elements. Remember that here we can observe that fact b1 union equals to b2, that is equals to S mod p. Okay, this is the basic thing you have to know. So here this set is n elements and this set will be how many elements? Tell me. This set will having the elements, total elements minus b1 elements. So how many total you are having? Tell me. P minus 1 by 2 minus n. So this is the cardinality of b2. So cardinality of b2 is equals to, let's assume this value as a some number, let's say t. Happy. So how will this set will look like? L1, L2 and so on, LT. Okay, where Li equals to same again A into merge such that, see, this is called such that in mathematical way, such that here Rk, I forgot to write if else, P by 2 where 0 belongs to 1 comma P minus 1 by 2 such that, tell me, Li less than P by 2. Remember that P is a prime, so prime numbers are always odd. Okay, so in the question only we are saying that take a odd prime number. So even prime means only 2, so we are ignoring 2, so odd. So odd by 2 value will be in the always points, not a integer form. Okay, this you have to remember. So that's it. So P by 2 is like it is in a fraction, so none of the value in this set will be exactly equals to P by 2. Why so? Why so means simple. P by 2 is a fraction. Okay, it contains the fraction, but we know that modulo of an integer will always be an integer only, so it should be, so the values can be P minus 1 by 2 is a possible, because if P is a prime, P minus 1 by 2, P minus 1 is a even, P plus 1 by 2, this value is possible, but P by 2 is not possible, means out of these values. Okay, I am considering this set and I am telling to you. Okay, nothing is, nothing more, nothing else, nothing less. Okay, happy? So from this, generally, see, what can you conclude here? Tell me. Generally, anything in the set, I have told already before. What did I told? Any value is always 1 to P minus 1. So this, from this, what can you conclude about range of these values, each individual value? So I know that this is coming from this set only. For this set, it is having 1 less than or equals to any value. So Rk less than how much? N not N, P minus 1. And but who will take care of this also? No, Rk should be greater than P. So combining this, what can I tell me? I can tell P minus 1. So Rk is basically an integer, so we can write like this, or what is the value of next integer? P plus 1 by 2 or Rk. So this is happily, there is no fraction, because P is a, what is odd plus 1 equals to even, odd plus odd is even. Okay, happy? So now from this, what can I conclude? Nothing can conclude, just it is there. So let's calculate the P minus Rk range. How will you calculate? Tell me. First we have to multiply this whole inequality by minus. Multiply by minus. So what will happen when you, it is the property that when we multiply with minus, the sign changes happens. So minus P by 2 greater than minus Rk greater than or equals to 1 minus P. Now add P to the whole inequality. This is called inequality. It is not an equation. Samjha? Equation will be like f of x equals to something, equals to will be there, but it is greater than like inequality called. Add P to inequality. So what will happen? P minus P by 2, P minus Rk. One. Okay, so from this, what can I conclude? P minus Rk less than P by 2. Happy? You got it? Now tell me, what is the values of range of Li? Range of Li can be, generally Li is also coming from this set. This set is having the property that every will be value 1 to P minus 1, because it modulo P, basic funda. So again Li is less than or equal to P minus 1, but under Li is less than P by 2. So less than P by 2 means what will happen? It's possible that 1 less than Li less than P by 2. So this is the basic funda you have to remember. Once you remember this thing, what you have to supposed to do means nothing. So so I'm saying one statement. I'm saying one statement. So I am saying that statement is perfect true. So let's investigate that. Okay, first I will tell about the statement. The statement is that considered a set X such that all X such that now calculate P minus R1 for each and every value. So what will happen, tell me? X1 equals to P minus R1, P minus R1, P minus R2 and so on, P minus Rn. Let's take this as a B2. So now I am saying that consider X should be X1 union B2. That means P minus R1, P minus R2 and so on, P minus Rn, comma B2 means what by L1 to LT, L1, L2 and so on, LT. Okay, happy? So now count what is the cardinality of mod X. Tell me. So the cardinality will be, it's nothing but how many elements here are there? N. How many elements are there? T. So mod X will be N plus T. What is T? T is nothing but P minus 1 by 2 T. Okay, P minus 1. So this is what you can conclude. This is normal bacha. There is nothing great about it. Okay, so consider this set X which is having all the elements P minus. So the short form is P minus RK comma Li, where K equals to 1 to N and L equals to 1 to T. This is normal basic fund. Okay, now what I am saying that means, and we know that 1 less than or equals to Li less than P by 2, 1 less than P minus RK less than P by 2. So this is what we have known. Each and every element in this set X is ranges from 1 to P minus 1 by 2 and mod X equals to P minus 1 by 2. Okay, so can we conclude like this? So X set is nothing but it contains 1, 2, 3 means okay, fine. So my argument, my statement, what I mean to say, my statement is that all elements in set X are distinct elements. So what do you mean by distinct elements? Distinct elements means everyone is different element. So let's just set consider this is like here, this is same, so this is not, it doesn't contain distinct elements. Okay, let's suppose 1, 2, 3. So all numbers should be different. So this set is a distinct, it contains distinct elements. All elements in set X are distinct elements. This is my statement. Now you have to question me that why so. So now I will tell about proof for this one. Okay, so in the proof step, every time you have to remember that RTP means required to prove, means what we have to prove means all elements set X are distinct. That means yes, X is nothing but P minus RK Li. So that it means P minus RK is not equals to Li. This is what you have to prove. Okay, for all K and I, where K ranges from 1 to N, and these are not equal, where all elements are equal. So now I prove like this. Okay, so basically this is like saying that our x1 is there na, x1, so x1 is not equals to b2. What is that? X1 is there na, x1 equals to all this one and b2, so x1 is not equals to b2. This is what I have going to say, x1 is not equals to b2. So proof we will do by contradiction. Okay, so assume that P minus RK equals to Li. So apply mod P on both sides. So what can I write in P minus RK mod P Li mod P. So from this what can I written, tell me? I can write like congruence or not? just a different form notation. Okay, this is normal, don't fear. Okay, I already told that we know that, let's say when C is congruent to d mod m or d mod, let's say f, so then I can say that C mod f equals to d mod f. Remember that this is a congruence, this is normal equals to. Okay, in this congruence we read as a C is congruent to d modulo f. Okay, happy. Now here how we will read C mod f. C mod f means remainder when C is divided by f. Happy? That's it, simple now. That's how I have written this step. Now I am using this step. Okay, Rk is nothing but Aj. Li is also Aj. Okay, where something j belongs to here. So I can use this fact now, right? Like this. So Rk is nothing but Aj mod P. So tell me, from this I can write that P minus Rk is equal to Aj is congruent to Li. Li also such that what? A is greater than P by 2. And what is Li? Li is again Aj mod P, no problem, but Aj is less than P by 2. So P minus Aj is congruent to how much value? Tell me. Simple bacha only. Li means so let's say since these should not be matched, let's consider as j dash, some other symbol. Okay, definitely it should be other symbol now. Okay, Aj dash mod P. Okay, now from this what I can write means P minus Aj mod P is equals to Aj dash mod P. From this what can I write? P mod P minus Aj mod P whole mod P equals to Aj dash mod P. So P mod P means it boils down to 0. So minus Aj mod P whole mod P equals to Aj mod P. See brother, remember that A epsilon P equals to A if A is less than P. Okay, that means A is less than P. So A can be from 0 to P minus 1. Let's when you consider about only positive numbers. Okay, this is basic funda you have to remember. So under what is A dot P whole mod P equals to, again since is this value, apply this above what you call conclusion. So similarly A dot P will be, let's say x. So x percent P. So x percent P means since x is a what, tell me? I always told A percent B always belongs to 0 to P minus 1. So x belongs to 0 to P minus 1. So since x belongs 0 to minus 1, x mod P will be x. So actually this should not be very dragged. Okay, these are small things you need to understand by yourself. Okay, by yourself only. So I can write minus Aj mod P Aj dash mod P. So A cancel, minus J mod P equals to J dash mod P. So I can write like this, minus J is congruent to J dash mod P. So J plus J dash is congruent to 0 mod P, like this. Okay, whenever you are converting to equals to congruence, you make sure that you keep it in the closure bracket mod value. If you keep normal like this, many people got confusion because of so many left the disinterest the subject because of small things they are not able to know. So because every time if you see that symbol you will get like mental. Okay, so this means that P divides G plus G dash. Okay, happy. So let's talk about, since J belongs to RRSM P, because of only now like we have written RK is nothing but how much AJ more P, where J is greater than P by 2. Let's say J is equals, list J and J dash belongs to RRSM. Since P comma J and P comma J dash equals to 1, we have theorem in SNS that AM equals to 1 and GC of A comma M equals to 1, that is equals to B comma M, then AB comma M equals to 1. Okay, this is basic thing, you have to understand it. So since we know that P comma J is equals to 1 and P comma J dash is equals to 1, see, don't fear about the by J and J dash, what the hell is that J dash is. So J dash is nothing but our friend only, but like how much friends it should be, like that I'm asking. So a friend means, I mean, it's a ditto but another notation. Okay, so I'm getting very sleepy now, so that's why I'm prolonging very so much. So AJ dash, so instead of J I written J dash. Okay, just to distinguish. Okay, by that what can we conclude, that P into J dash equals to 1. This is okay, happy. Now consider what is J. J is considered as 1 minus P by 2. What is J dash? J dash is considered as P minus 1 by 2. So when you add J plus J dash, it boils down to P 2 into 2 P minus 1. Now tell me whether P divides J plus J dash or not. It is like 2 divides 1 or not? Answer is what? No, right? No, just like this here also P divides, P doesn't divides from this fact, and this is from our assumption by applying a logical steps. So what do you mean by logical steps? So logical steps means steps which is having a logical outcome. Again I am talking about logical. So see brother, simple terms is logical means just by thinking it you are writing down, able to write down, and you finally conclude those things. This is our assumption. Since both are colliding, so what can we can say? It's a contradiction. What can you can say? And basic contradiction. Once it is a contradiction, so what will happen? Our assumption is wrong. What is our main assumption? You should not forget about what is your main goal when you're reaching. Keep on doing some modification. So the question is that here our assumption is here that all elements are equal, means some of them are equal. This assumes that some of them are equal. So since like you want to know whether all are equal, but we came across, so this contradiction of the statement will be all elements are distinct. Samjha? That means P minus RK never equals to Li. This is what we have proved it. Okay, that means indirectly we are saying that all elements in the sets are distinct elements. If you accept this property, then we can move further. Okay, so in the further mode, what will you say? So S dash will be like P minus RK into Li. Okay, P minus I into Li. Sorry for the inconvenience, I'm getting so much sleepy now, but I have to record now only. So you have to keep speed in 2x mode. If you are using like third party, what is called that third party in Google, you are saying third party applications. So using that we can increase the speed to 4x or 5x or 10x, whatever you are want. Okay, by that you can increase. Now I am saying that all the elements are distinct and mod S dash is equals to P minus 1 by 2. Okay, so since all elements are distinct, can I say that S dash will looking like basically like this? Yes, I can say this is what exactly I want to prove. S dash is this is S dash. Why means I am saying here na mod S dash is nothing but P minus 1 by 2. Why so means I have done previously, you can refer it. Okay, where I have written means here mod x equals to n plus t will be P minus 1 by 2. Sorry, this is known as x in our case. This is known as x and this is known as x. Okay, since it is having, and everyone in this element are distinct and it's having the value less than P by 2 and 1. What? Bi is less than P by 2 and 1. Since it is happens so, then I can conclude that overall the terms will be okay. At the end of the day, the set x looks like this. This is how it looks. Okay, this is the main point you have to remember. Once you conclude about, now take the product of this element. So phi of x. So phi of x is nothing but phi of j, where j equals to P minus 1 by 2. That is P minus 1 by 2 factorial. This is the basic thing I want to tell. So this can be written as how? Tell me. This can be written as pi means multiply all the elements where P minus RK into Li. So this can be written as, I am saying this can be written as like this. So I can separate it like this, pi where k equals to 1 to n, where phi I equals to 1 to t. Okay, Li. So now what I want to tell to you is that consider this one. So basically these two are equal. This finally I have got like this. So you know that AB mod P, how much? A mod P, B mod P, whole mod P. Samjha? One kick I will give, bhaiya. If you don't understand, I will give one kick on your face. Okay? Not to you, sorry, to myself. I am sleeping because of this. So what will happen? Mod P, okay, is equals to, so this, because of this I can write like this, pi of P minus k. So you know, like pi a mod P, let's say AI is equals to like this. I can write phi of a into mod P, means a into mod P, of course mod P. This is how I written. So P minus RK whole into mod P. This is how, okay, where pi equals to into Li whole mod P. So what will happen? Tell me here. Pi into minus k mod p. You know why it happens? So p minus rk mod p equals to p bar p minus rk mod p. So p bar minus to 0 and rk mod p. So I have written that minus rk mod p. This is how I have written. Okay, so small things. See, I am telling small things because that I don't want anyone to lose this information. This is like this should be understood by everyone. Okay, so minus become here, I written like this, and minus by li mod p, li mod p and mod p. So since because of this form, can I write from ls test to this is looking like a RHS form. So can I write like this, minus 5 into rk into bi mod p. Okay, happy like this. So into current mod p equals to, so again from this I can write like this, just like congruent, because since we are habitual, into mod p. Happy? You understand why I have written? Again I will tell small. A is congruent to b mod m. That means a mod m equals to b mod m. So implies by implied. If and only if and only if. Happy? So again, what is arc and bi? What is pi means? What do you mean by pi? Pi means product of all elements ranging from like whatever range I have mentioned, just like sigma. Okay, sigma, you understand? Summation of all elements. So what is arc and li? Arc and bi, sorry, not bi, li. This is l, sorry. So arc into li. So it will be like where I have written this partition, sorry, here. So this is this is bi, this is ri. So phi of b1 into phi of b2. So this is what I have written indirectly, means don't take meaning of this directly. Okay, just each elements of phi of phi. So basically I told na b1 union b2 how much? S small p. S small p contains all these values. Okay, samjha? So how can I written? Tell me. So I can write like this na. Let's say not convert to congruent for your understanding purpose only. See these basic things I am telling in a complicated way. Okay, so that you can complicated way means deeply, which takes so much of time. See, hell of time. 45 minutes means if I tell, you will die. Okay, so minus into rk into li. So phi of rk into phi of li. So phi of rk means it suggests that's r1, r2, r3 and so on, rn, where li, l2 and so on, ln. Okay, it's saying that mod p. It's basically whole saying that since I said na x1 union x2, b1 union b2 is nothing but our s mod p. So s mod p, what are the elements in my small p? Tell me. 1a mod p into 2a mod p and so on. How many are there? Tell me. And so on. P minus 1 by 2 a mod p of whole mod p. So this can be overall written as a can be pulled out. So minus a power m, and it will be 1 2 3 4 and so on, p minus 1 by 2 whole mod p. This is how I written. Okay, see, for your purpose generally sir will directly go into this step. Sir will not write clearly, okay, but I am writing clearly. Because why I am going to this step means because of this theorem. Since if I am having this format RHS LHS, so then I can write RHS as a LHS equivalent. Okay, that's why I am written like this. Otherwise it's not for like fun for me. Okay, minus a power minus 1, what will happen? P minus 1 by 2 mod p. Okay, here p minus 1 by 2, this is for whole thing. Okay, here mod p, that's mod p is there. I kept equal symbols. Okay, but yeah, see, let's see fast, very fast. So from this again I written as p minus 3 mod p into p minus 1 by 2 whole mod p whole mod p. So p minus 1 by 2 factorial into mod p. So this one will be cancelled. Okay, this one you have to understand. Okay, again I will explain why we are cancelling like this. Okay, if you see, everything is mathematically is there. Okay, don't worry. Why so? Because this is like a constant. I can pull outside now, a into p minus 1 by 2 mod p. Now I can write as p minus 1 by 2 whole factorial mod p and mod p. Okay, this is some constant by you understand? Okay, to simplify, see, this because of this mod p we are talking about congruency. Okay, this is like, see, to cancel this one we involve so much of trouble na. So for this, like, how can I written from this theorem, like RHS to LHS, how can I tell me? A power p minus 1 by 2 p minus 1 whole factorial mod p. Okay, p minus 1 by 2 whole factorial mod p. So this can be written as p minus 1 by 2 factorial is congruent to minus a power p by 2 p minus 1 by 2 factorial mod p. This is congruence. Now I can cancel like this. So okay, after I cancelling that, what can I say? Minus 1 has been translated here, a power m minus 1 by 2. See, wait a minute. Here what I have done mistake means, whenever I written pi is with here k, where k is running, tell me? K is running from 1 to n. So when I written minus will be whole power n. So minus 1 whole power n, minus 1 whole power n, minus 1 whole power minus. Sorry, extremely sorry. So when I bring it minus 1 whole power mod p, we know already that a by p is congruent to a power p minus 1 by 2 mod p. So from both things, what I can, a by p is congruent to minus 1 whole power mod p. So this is can be written as a by p mod p equals to minus 1 mod p. So this exactly, this value is always either plus 1 or minus 1. We have seen it. So I can write it as directly a by p, and this value will be plus or minus 1. So this is our solution. Okay, basically, see, understand how from this step to this step. So if you not get it, just rewind and listen my explanation. Samjha? This is basic concept. Just like I told na, this concept means small thing. A percent p equals to a. In which case it will happen when a belongs to, when a is less than p. Okay, Hare Krishna, completed, successfully completed. So one more thing, why I am not able to write successfully like this minus 1 left side means it's a property. Okay, let's say a equals to minus b. Can I write minus a equals to b? Yes, of course. So this is the beauty, means generally a equals to 2 square b. So if I write it, I can write minus 2 power 2 a equals to b. Okay, but suppose if a equals to minus actually 1 minus 1 whole power n b. Then if I take right side, it should be minus n a equals to b na, but still I'm writing a equals to b because that is the beauty of it. Okay, this is the beauty thing. Like I discussed this in last class also, so no need this is repetition. Okay, finally this is the conclusion. Happy? So anything doubts you can comment down in the, or you can contact me directly. Okay, thank you, bye.